This video is going to go over the p-value of hypothesis testing with a means test. So first of all, what is a p-value? It's the probability of getting a sample test statistic that is at least as extreme as the one found from the sample data if the null hypothesis is in fact true. So same as the formal test, we will be comparing a sample to a claimed value using a null hypothesis. So we're going to decide, do we reject or not reject the null hypothesis? So many of the steps are actually the same as in the formal hypothesis test if you've watched that video already. So steps 1 to 3 and step 6 are exactly the same as the formal test. But in case you haven't watched that, or in case you haven't remembered it yet, we'll look at these steps. So the first is identify the claim, put it in symbolic form. Second is using the symbolic form, state the null and alternate hypotheses. Third, decide on that significance level, alpha. Fourth, calculate a p-value using a test statistic score. So we still have to calculate the test statistic as we did in the formal hypothesis test, but we don't calculate a critical value, instead we calculate a p-value. Now what the p-value is in terms of that at least as extreme, if it's a right-tailed test, we look at the area to the right of our test statistic. If it's left, area to the left. And if it's two-tailed, we go to the far side and then double it. So we take twice the area of the extreme region bounded by the test statistic. And reject the null hypothesis if our p-value is less than or equal to alpha. So our decision step is a little different, right? And instead of saying, is the critical value inside, is the test statistic inside the critical region, we're going to be saying, is the p-value less than alpha? And last is the same, we write a statement addressing the claim or question. So these two methods, the traditional method and the p-value method, one is not better than the other, they're both the same length, they're just two options. They come to the same conclusion. So to look at that, we're actually going to look at the same examples that I looked at in the formal hypothesis test video, only this time we're going to do them using the p-value. So we'll see that many of the parts are the same if you compare the two. So first of all, we read our question and we identify the claim, and we see that we're testing that the mean time worked is 500 hours. So that claim is going to be equals, and so we have the null hypothesis. Our alternate, opposite to equals, is does not equal. So when we have equals and does not equal, we get our two-tailed test. And if we look at the values that we have in our question, we've got our standard deviation of 12 hours. We've got a sample of 50 weeks. We're using a 5% significant level, and our sample average is 498.5. So that identifies our other variables. So to find our p-value, we first need to calculate our test statistic. So that's our z-score formula in this case, because we know the sample mean and the population standard deviation, as well as the values from our claim. I strongly encourage you to take a moment to do the calculation, but it works out to negative 0.88. So the p-value says, well, let's take that value and put it on our chart. And calculate the area more extreme than that. So if that's our 0.88, the area more extreme is going to be on this side. But because it's two-tailed, we also have to add the mirror image side. So if we look up our probability of z being less than 0.88, that's just looking it up in our z-score table, it's 0.1894. Right, so that's going to be this area here, but then this area is also equal to that. So we double it to get a p-value of 0.3788, or if you prefer, 37.88%, which we're comparing to our significance level of 5%. So remember, our question is the p-value less than the significance level? Well, 37% is definitely not less than 5%. So the knots still go together. It's not less, so we do not reject the null hypothesis. And if we're not rejecting the null hypothesis, we're also not rejecting the claim in this case, because our null hypothesis is our claim. So again, using that flow chart that we had in the earlier video, does the claim contain equality? We said yes. Do we reject the claim? We're saying no. So there's not enough evidence to reject the claim. Don't forget to write your statement very clearly, including that original claim. So not enough evidence to reject the claim that the mean time worked is 500 hours. Okay, next example. Again, we can look at that claim from the perspective of the question being asked. So here it says, does the data support your belief that the average price is higher? So average price is higher is going to be our claim, greater than 1.157. So higher, no equals in there, it's going to be our H1. H0, our null hypothesis, has to have the equality. So our mean equals 1.157 can get used. Sometimes people like to show the direct opposite to the claim, in which case you would say less than or equal to 1.157. I will note that when you're typing these into MyLab, you definitely have to use the equals. It being computer marked, it's picky about which way you put it. Either way, we look at our alternate hypothesis to decide if it's left, right, or two-tailed, and we see greater than points to the right, so it's going to be right-tailed. Identify all of our other variables. So we have our sample average, we have n, we have sigma, and we have our significance level, alpha. Again, we plug that into our z-score calculation. I recommend you pause and make sure you can get that number. This time it works out to 4.32. So on our diagram, that's going to be here, 4.32. And so our p-value is this area here. Now if you try and look this one up on your table, you'll notice that 4.32 is right off of the table. It's a very high z-score. And there's a note on your table that says for values above what's on your table, use 0.9999 as the area to the left, right? So that's going to be this area here. So our p-value only works out to 0.0001. In other words, 1/100th of a percent. Our decision step is this p-value less than alpha? And p-value is definitely less than alpha, right? 0.0001 is less than 0.01. So we're going to reject the null hypothesis, right, when our answer is yes. Again, let's look at our flowchart on this one. So does the claim contain equality? We said no, it's less than, so we came down here. Do we reject the null hypothesis? So is the p-value less than or equal to alpha? We said yes. So there is enough evidence to support the claim. So again, we're saying we rejected this one. This one here is wrong. So we're supporting this one. So our conclusion is going to say there is enough evidence to support the claim that the average price is higher than $1.157 per liter. If you compare this to the other video, these two questions that we did with the traditional method, we came to the exact same conclusion. So different methods, same result.